So for this example, what we can go ahead and do is start off with what the constants are. And we know in order to have to solve this and find all the tensions, we're going to have to find the sum of the forces of x, which equals 0, and then the sum of the forces of y, which equals 0 as well. So to start off and categorizing it, we were told in this example that T3, let me go back, that T3 equals 40 newtons, and T3 is this force. Now let's go ahead and start off and establish all of the tensions here that are present in this example. So I'm going to go ahead and start off by recreating this more or less like this, right? We have this as T1 and we have this as T2. Now, using another color, I'm going to go ahead and say the other tensions that are present here are here. And since we know that this angle is 10 degrees, this angle must be 10 degrees as well. And we're going to call this arrow T1 of x, which equals T1 cosine of 10. Now, using the other color over here for T2, we can identify this. We know that this angle is 30. So this angle must be 30 as well. And we're going to call this T1, T2 of x equals T2 cosine of 30. Now, we can find the y by going up, and that is T2y equals sine of 30. Using again that same one, and going back here, here, T2 of x, T2 of y, equals sine of 10. Now, that's basically all that we have for this. And then we know here that this is that. So going back to doing the rest of the example, to find the sum of all the forces of x, that's going to equal T2x minus T1x is going to equal 0. We've already defined what T2x and what T1x are. So T2x is T2 cosine of 30 minus T1 cosine of 10 equals 0, which is equivalent to, this is going to be 87 T2 minus 0.98 T1. So if we want to, that's going to be our sum of x. Now, we can do the same thing for the y. The sum of the y is going to equal all the forces of y. What's present in this example is T2y plus T1y minus the force going down, which is T3, which we know is 40 newtons, and that equals 0. So we know that T2y is sine of 30 Ty plus sine of 10 T1 minus 40 newtons. Now, using this example, using the first example that we did here, what we can do is solve for T1, for example. So we know that 0.870 T2 equals 0.98 T1, which means T2 in terms of T1 is going to equal 1.1 T1. So we can go ahead and plug that in here. So we see here that sine of 30 Ty 2 sorry, this is actually wrong. So we have here that sine of 30 equals 0.5. And we know that Ty2 in terms of 0.5 times 1.1 T1, and this is y, plus sine of 10 Ty1, and 10 is 0.17 T1 as well. Y is equal to 40 newtons. So here we have 0.5 times 1.1 plus 0.17 is equal to 0.72 equals 40 newtons. Divided by 0.72, 0.72, remember this is T1. So we have 40 divided by 0.72, which is equal to newtons is equal to 56 newtons equals T1. So when we have T1, for example, we can go ahead and plug that in to this equation, where it says T2 is 1.1. Here we have T1 equals 56 newtons. T2 is equal to 61 newtons. And T3 is already our given, is equal to 40 newtons. These are our answers.